It's Tuesday, February 10th, 2026. And what I'm about to show you represents the most catastrophic polar vortex disruption in recorded meteorological history. We are witnessing, in real time, the complete structural breakdown of the Arctic's most powerful circulation system, and the implications for over 100 million people across North America and Europe are nothing short of terrifying. The stratospheric warming event that began in late January has now reached what scientists are calling a textbook extreme intensity, with temperatures 30 kilometers above the Arctic spiking by more than 50 degrees Celsius in just a matter of days. This is not gradual climate change. This is an explosive atmospheric catastrophe that is fundamentally reshaping the weather patterns of the entire Northern Hemisphere as I speak to you right now. The polar vortex, which normally acts as a massive fence of winds spinning at over 200 miles per hour to contain the coldest air on Earth within the Arctic Circle, has now completely split into two separate cores. Analysis at the 10 millibar level in the mid-stratosphere shows a distorted, oval-shaped circulation that has effectively torn itself apart under the pressure of unprecedented warming waves. What we're looking at is not just a weakening of the polar circulation. This is a complete structural failure that is releasing Arctic air masses directly into populated areas that are completely unprepared for the brutal conditions that are now inevitable. The current analysis shows one primary lobe of the fractured polar vortex now centered directly over North America, with a secondary core positioned over northern Eurasia. This split configuration represents the worst-case scenario that atmospheric physicists have been warning about for years, because it means that instead of cold air being gradually released in manageable doses, we're now looking at massive, sustained dumps of polar air that will persist for weeks or potentially months. Over 100 million people across the United States and Canada are currently under various forms of winter weather alerts, and that number is expected to climb dramatically as the full effects of this vortex split become apparent. Major metropolitan areas, including Boston, New York, Detroit, Chicago, Minneapolis, and Toronto, are already experiencing wind chills dropping as low as -30 degrees Fahrenheit, with some locations recording actual air temperatures that haven't been seen since the historic Arctic outbreaks of the 1980s. The stratospheric warming event driving this collapse has reached intensity levels that meteorologists are describing as exceptional and unprecedented. When atmospheric scientists use language this strong, you know we're dealing with something far outside the normal range of weather variability. The warming in the stratosphere has created a cascade of atmospheric disruption that is propagating downward through the entire column of the atmosphere, fundamentally altering pressure patterns and wind flows across thousands of miles. Forecast models from the European Center for Medium-Range Weather Forecasts indicate that this polar vortex split will reach its maximum intensity around February 15th, which means we're still in the early stages of what could be a month-long period of historic cold. The GFS stratospheric polar vortex structure analysis shows two distinct lobes continuing to separate, with one displaced over northern Eurasia and the other extending toward northeastern Canada and Greenland. This configuration creates a direct pipeline for Arctic air to flow southward into populated areas of both North America and Europe. The mechanism driving this catastrophic breakdown involves massive, upward propagating planetary waves that have been disrupting the stratosphere since late January. These waves, originating over the North Pacific and western North America, have created persistent ridging patterns that enhanced vertical wave propagation directly into the polar stratosphere. Think of it as atmospheric pressure waves literally hammering the polar vortex from below until it finally fractured under the stress. What makes this event particularly dangerous is the interference from the Madden-Julian oscillation, a powerful tropical atmospheric wave that is complicating the typical response patterns we would expect from a stratospheric warming event. This interference means that the cold air release is not following predictable patterns, making it extremely difficult for emergency management systems to prepare for the specific impacts that different regions will experience. Temperature forecasts for the next 5 to 7 days confirm a direct corridor of polar air extending from northern Canada deep into the central and eastern United States. Only the Southwest and Florida are expected to be largely spared from the initial wave of Arctic air, but even these regions could see unprecedented cold as the pattern becomes more established over the coming weeks. The Arctic Oscillation has plunged into a deeply negative phase, which historically correlates with sustained periods of below normal temperatures across the mid-latitudes. The North Atlantic Oscillation is also showing strong negative values, indicating that the blocking patterns over Greenland will persist and continue to direct Arctic air masses southward into both North America and Europe. Europe is facing its own version of this crisis, with northern regions already experiencing significant temperature drops and winter storm activity. The elongated polar vortex structure is creating sustained northerly flow patterns that are dragging Siberian air masses westward into Scandinavia, the United Kingdom, and eventually into Central and Western Europe. While the immediate impacts in Europe may be somewhat less severe than what North America is experiencing, the duration of cold conditions could be even longer due to the way the split vortex is positioned. The three-dimensional analysis of this polar vortex breakdown shows Arctic air being displaced in multiple directions simultaneously, creating what atmospheric scientists are calling a polar air flood across the mid-latitudes. This is not a temporary weather event that will resolve in a few days. The structural changes to the polar circulation suggest we could be looking at sustained below-normal temperatures extending well into March and potentially affecting the transition into spring. Wave activity analysis shows a classic signature of wave reflection, where atmospheric energy travels up and east over Asia, reflects off the disrupted stratospheric polar vortex, and then heads down and east over North America. This creates a self-reinforcing pattern where cold air is continuously transported from the Arctic southward into the central and eastern United States. The westward wave tilt over Asia and eastward wave tilt over North America are textbook indicators of this reflection process, which typically occurs with severely stretched or split polar vortex configurations. The implications for infrastructure and public safety are staggering. Power grids across the affected regions are about to face demand levels that could exceed their capacity, particularly in areas that are still recovering from previous winter weather events. The combination of extreme cold and potential power outages creates life-threatening conditions for vulnerable populations, including the elderly, homeless individuals, and those without adequate heating resources. Agricultural impacts will be severe and long-lasting. Livestock operations across the affected regions are facing conditions that could result in significant animal losses, while crop storage facilities and greenhouse operations will need to implement emergency heating measures to prevent catastrophic losses. The cold air masses being displaced from the Arctic are dry as well as frigid, which means that, in addition to dangerous temperatures, we're looking at very low humidity levels that can create additional stress on both human health and agricultural systems. Transportation networks are already beginning to show strain, with airlines proactively canceling flights and railway operations implementing cold weather protocols that significantly slow service. Highway departments across the affected regions are preparing for extended periods of hazardous driving conditions, with the added complication that road salt and de-icing chemicals become much less effective at the extreme temperatures we're forecasting. The energy sector is bracing for unprecedented demand, as heating systems across the region operate at maximum capacity for extended periods. Natural gas prices are already responding to anticipated demand, and utility companies are implementing emergency protocols to ensure supply reliability during what could be weeks of sustained extreme cold. What's particularly concerning is that this polar vortex split is occurring during a period when many communities are still recovering from previous winter weather disasters. Emergency shelter systems are already operating near capacity in many areas, and the addition of sustained extreme cold creates compound vulnerabilities that emergency management systems are not designed to handle. The Canadian long-range model shows continued cold air support over Western Canada and the northern and central United States, extending well into February and potentially beyond. This represents a fundamental shift from the milder winter patterns that many regions have experienced in recent years, and signals a return to the type of sustained Arctic conditions that have not been seen since the major polar vortex disruptions of previous decades. Arctic sea ice conditions are contributing to the severity of this event, with negative anomalies strongly weighted toward the North Atlantic sector relative to the North Pacific sector. This configuration historically correlates with weaker polar vortex circulation and increased probability of major disruption events. The current sea ice distribution, particularly the reduced coverage in the Barents-Kara Seas and near Greenland, has provided the background conditions that made this type of catastrophic breakdown more likely. Looking ahead, ensemble forecast data indicates that the polar vortex will likely remain in a disrupted state through at least the middle of February, with the possibility of additional splitting or stretching events as the stratospheric warming continues to propagate downward. The coupling between the stratosphere and the surface is expected to strengthen over the coming days, which means the full impacts of this collapse have not yet been felt. Recovery from this type of polar vortex disruption typically takes several weeks, and in some cases can persist for months. The structural damage to the polar circulation system means that even after the immediate cold air outbreak begins to moderate, the atmosphere will remain in a configuration that favors continued temperature departures from normal and increased probability of additional winter weather events. The comparison to previous major polar vortex events shows that this 2026 collapse ranks among the most severe on record. The combination of the intensity of the stratospheric warming, the completeness of the vortex split, and the timing during an already active winter season creates a perfect storm of conditions that could make this event historically significant. Public health officials across the affected regions are implementing cold weather emergency protocols and opening additional warming centers to accommodate the anticipated increase in demand for emergency shelter. The sustained nature of the cold outbreak means that traditional short-term emergency responses will need to be maintained for much longer periods than typical winter weather events. This polar vortex collapse represents a stark reminder of the power of natural atmospheric systems and the vulnerability of modern civilization to extreme weather events. The scale and intensity of this disruption serve as a case study in how small changes in the upper atmosphere can cascade into major impacts on human society and economic systems across multiple continents.